Hi friends and my dear students. Today in 12th Physics, second volume 8.21, as per heading Atomic and Nuclear Physics. Atomic and Nuclear Physics 8.21, JJ Thomson experiments. Actually, from this experiment, we are going to determine the specific charge of an electron. What is meant by specific charge of an electron? When we say the charge of the electron is nothing but E, and specific charge of an electron, it is nothing but E by m, where m equal to 1 unit mass or 1 unit mass. Such a tremendous equation is called E by m value was determined by JJ Thomson. If suppose the mass equal to 1, then this charge of the electron is called specific charge of an electron. That's why in ancient days, JJ Thomson was considered as a landmark experiments for the both of modern physics. This experiment was considered as a landmark experiments for the both of modern physics in 1887. In 1887, this is very important in physics generally. Okay, now we are going to see the construction of the tube, construction of the tube. Whether you have to, it is difficult to draw the figure or magnetic field like this, then you can draw like this figure, like this. It is very easy, but as far as concerned in your textbook, it is very difficult. You put south pole and north pole like this. That's enough. That's enough. But this is enough for to explain the north pole and south pole. Here, south and north. This one is called north. Now, the construction of the tube was explained very simply, was explained by JJ Thomson. He considers a highly vacuum tube, highly evacuated tube called discharge tube. And here, the cathode terminals are connected with the low tension battery of negative, whereas the anode and cathode are connected with the high tension of battery. When we are applying the V voltage to the terminal of anode, then the scattered electron by the cathode are hitting the anode, then there may be a pinhole in the anode itself. That's why the scattered electron are converted into a small ray and passes through this hole itself. The ray which will hit straight away to the screen at the point O. Whereas here on the screen we are considered as a zinc sulfide coating. Zinc sulfide coating. That's why whenever the electron ray hitting on the surface of the screen, then the particular point are eliminated. Now we are applying the electric field as shown in the second figure. This is called first figure. In three-dimensional, we cannot be able to draw the figure as shown in the figure. For our convenience, let us consider the second figure to explain the term clearly. Suppose if you are applying the electric field like these, perpendicular to each other, negative is downwards and the positive plate is upwards, then what happened? And because of this electric field, then if there is no magnetic field, consider that there is no magnetic field, only electric field is applied, then the particle move towards upward, and there is no hitting on the surface at the point O, but instead of O, the ejected ray or cathode ray which will hit the point P, OP, at a distance of OP, the reflection was made by of electric field. In suppose you are applying the magnetic field in perpendicular to the electric field as shown in the figure second, this is called electric field, negative and positive, whereas north and south magnet are perpendicular to the electric field like this. Then E is the electric field applied and B is the magnetic field applied. Here the force Fe is called force due to electric field and force B is called force due to magnetic field. Both are opposite and equivalent. The magnitude of the Fe vector is equal to the magnitude of the Fb vector. Both are same. Then the deflection may be cancelled to each other, because if the electric field pull the point O to P, the magnetic field again pulling towards downward, therefore there is no deviation, then the cathode ray straight away falls on the surface of the O. This is a basic apparatus construction that was made by JJ Thomson. As per voltage we are applied here V. Now applied electric field E on the charged electron E. Therefore E into E, that's equal, here I already told electric field equal to magnetic field. So what is called electric field? E is the electric field of the charge. This is called electric field energy, that is equal to BeV. B is the magnetic field, E is the electric field. Both sides are E, therefore V equal to E by P. This is called equation number 1. This is called equation number 1. And this equation is known as, we find the velocity of the electron, moving electron, V equal to E by B. That is the first equation we derived. Okay, first part over. Second part, we have to consider sorry, determination of the specific charge of an electron. How can we determine the specific charge of an electron? Very simple and very easy. Now we are applying the voltage V to the terminals in between cathode and anode, so that the scattered electrons are accelerated with the help of this potential V and move towards anode. At the point anode, then the energy or E into V, energy are completely transferred to the kinetic energy of the electron, so that this ray, kinetic energy of electron, carries this electron to the screen. That's a famous equation, so that we can write the total energy of the potential energy equal to kinetic energy of mv square. But we know the value of the help of this equation 1. We can write this is nothing but m into E square by B square. E square by B square. But we want to find out the value of m, and so that we have to bring this is in right hand side and m is to the left hand side. What will happen? E by m. E by m, that's equal to 1 by 2 E square by B square into V. This is the equation to determine the specific charge of an electron. that is unit mass of electron, that is called specific charge. Here in this equation we know the value of E, applied electric field, and know the value of applied magnetic field as well as the value of the potential that we are applied to the anode between and cathode terminals V, so that he find the value that is equal to 1.7 into 10 power 11 coulomb per kilogram, or coulomb kilogram power minus 1. This is the answer that he got for specific charge of an electron. This is a very fundamental proof of a specific charge of an electron when we are applying both electric and magnetic field. This is the first condition. Here in first condition we are applying both electric field and magnetic field. With due to the equivalent force, there is no deflection. That's why we are calculating. In second case, when we are applying only electric field, in absence of B, only electric field, no B. That means we are not applying the magnetic field. We are applying only the electric field. So that we deflection of the specific charge of an electron by applying only electric field. That's the thing that we are going to derive. Now, F into E is nothing but E into capital V, because E into capital E. This is called electric field on the charge of the electron E. Therefore, electric field is nothing but E into E. Now, as per the Newton's second law, we know that F equal to ma. Instead of F, if you are putting Fe, that's equal to m into A suffix E. That is electric field force. It is not here acceleration of an electron, so that we can equal both equal to each other. Substituting the value of Fe here, then we get m into Ae, that's equal to E into capital E. Here we want to find the value of acceleration of an electron. Therefore, Ae, that is equal E into capital E by m. This is called equation number 2. That is, here in the first equation we have to find the value of velocity of an electron. Here in second case we are determining the value of acceleration of an electron. That is a difference. When we are operating electric field itself, then we have to calculate acceleration of electron is nothing but E by m. Okay. Now we have to consider the third figure. Now here the terminals of cathode emitted the electron ray with the charge G with the velocity v. And travel in straight line manner and hit the surface at the point O. Okay, no problem at all. Now we are applying electric field itself. Here we are applying electric field such that is called E. And because of this electric field, the negative plate is downwards, the positive plates of the electric plate is upward, so that the positive plate which will attract the attractive force to the electron, therefore, and the negative plate which will give the repulsive force, so that this electron ray which move towards upwards. Okay. it moved towards upwards. The initial velocity, here the direct velocity straight in the straight line manner, v is constant. Here, when we are applying electric field, then it tends to move upward, but initial velocity at the point turning to the moving turn to move upwards, u equal to 0. Then by seconds it may be increased, but at the starting point u equal to 0. Now you have to imagine at a particular distance the displacement of this electron ray make a distance center point to the y dash. Now at last it hit the surface and the displacement is considered to be y. Here y, the displacement y is proportional to y dash, or y equal to c into y dash. That's a very important question. First. The second thing, if you consider the length of the plate is called L and velocity of the electron is called v. So the time taken to cross this plate L with velocity v, distance traveled by the particle by the velocity, therefore t equal to L by v. These two equations are we are determined. This is called third, this is called third, this is called fourth. We have to determine value of y equal to cy dash and t equal to L by v. Are you clear? But in general, we already know the displacement equation. S equal to ut plus of at square. S equal to ut plus of at square. Here the displacement is called y dash. Initially we have to consider y dash. Therefore y dash equal to u means 0 and a means ae. When the product of 0 into t equal to 0, therefore only one term, that is called ae into t square. Are you clear? Yes. Now you have to consider this is equation number 5. In this fifth equation, we know the value of ae from the value of equation 2. This is called equation 2 and this is called equation 3. This is called equation, as per equation 3, we know the value of t. As per the equation 2, we know the value of ae. Substitute this value, then we get 1 by 2. ae is nothing but e into small e into capital E by m, and t equal to L square by v square. Are you clear? This is called y dash. But already I wrote y is nothing but c into y dash. You have to substitute the value of y dash. Y dash here c into of e capital E by m L square by v square. Now, by simplifying the equation, we have to substitute the value of v. We already derived an expression for v equal to nothing but e by b. V equal to e by b. Substitute this value here. We get c equal to 1 by 2 e by m into capital E L square by v square. Instead of v square, you have to substitute e square by b square. That is equal to, that goes upper. This goes upper. That's why we finally get the equation y equal to c of e by m. 1 e are cancelled. Then remaining that C, or remaining that C by 2 E by M L square B square by E. But we want to know the specific charge of an electron. You have to keep in the left hand side itself, remaining all you have to bring to the right hand side. And what happened? 2y by E. 2y by E by here in the L square B square are downwards, therefore, downwards, that's why 1 by E L square B square. This is the value of, this is the value of E, specific charge of an electron. Specific charge of an electron is given by the equation 2y 2 y that is equal to C into 1 by 2. C into 1 by 2 E by M L square B square by E. L square B square by E. That's all. Now we have to substitute the known values. We have to substitute all known values because Y is the displacement that was made on the screen. E is the electric field that we are applied. L is the length of the plate that we are utilizing. B is the magnetic field. On substituting these values in the standard equation, we get E by M that is equal to 1.7 into 10 power 11 coulomb kilogram power minus 1. This second time, Thomson proved the specific charge of an electron is the same as what we already determined the E by M, specific charge of an electron, when we are applying both electric and magnetic field. Second time, he proved when we are applying only electric field, then there is no change in the specific charge. Then the value is the same as the prior one. Now, third, again he want to prove one another value. Instead of electric field, he applied, consider only magnetic field. Again he want to prove, instead of electric field, he is not allowed to apply the electric field, but he has applied only magnetic field. What happened here? Now we are applying magnetic field that is called force due to magnetic field. It is nothing but what is already I denoted BeV. This is charge of electron, velocity of the electron, applied magnetic field. Fm that is equal to BeV or EVP, whatever it may be. Right. Now, another thing that may be happened here, when we are applying this magnetic field itself instead of electric field, if you are applying fast moving electron with velocity of E from cathode terminals, here there may be a displacement on the screen, right, 0. If you are applying magnetic field, then it may be turn like off path, off circle like this. This is called off path circle, off semicircle, or make a semicircle like this. That's why we have to consider the radius of this semicircle is called centrifugal force, and because of the applying magnetic field leads to centrifugal force to the electron, so that we know the value of centrifugal force. It is nothing but mv square by capital R. But we have to substitute. These both are equivalent. Both are equal. Therefore, BeV equal to mv square by R. mv square by R. This is a fantastic phenomena that we are going to derive. Now, 1v is cancelled. 1v is cancelled. And we have to bring m here. Then e by m is nothing but v by b into r. v by b into r. But we already know the value of v equal to e by b. We know the value of e by b. Applying here, then e by m, that's equal to e by b square r. b square r. This is the final equation he got, and substituting the known values electric field, magnetic field, and the radius of the semicircle, then he got the value 1.7 into 10 power 11 coulomb kilogram power minus 1. So whatever it may be, the three things, whether they are applying electric and magnetic field, the specific charge 1.7 10 power 11 coulomb per kilogram. Again, in options of B, only applying electric field, then the specific charge which will be the same in the prior result. The third one, in the options of electric field, he only applied magnetic field. Again, he got the same value. So, three times he proved that with the help of electric and magnetic field, the specific charge is equivalent to 1.7 in 10 power 11 coulomb kilogram power minus 1. By applying electric field, the same specific charge. By applying magnetic field itself, he got the same value. This is a very good conclusion, was explained by JJ Thomson. That's why it is considered to be a very fantastic experiment to find the determination of the specific charge of an electron. I hope you understand very well, clearly each and every steps. If it is not possible to draw the figure as shown in your textbook, you can simply draw like this. This is enough for getting more marks, full marks. I hope you may be happy today to answer this question. So try to subscribe those who are not subscribed my channel. Those who want to continually listen my channel, you have to click all bell. Then each and every class will knock your door. Then you will able to receive something more from me. Thank you, my dear friends and my dear students.